Good afternoon, good evening, or good morning, depending on where you are in the world. We'd like to present to you my new series called My Electronic Studies, or My Electronic Study. Studies. Um, so I'm going to do this one at a time. I'm going to try to do this every day or every other day, Monday through Friday, because I'll be alternating with other courses that or other things that I'm studying as well. So, um, yes. Let's get to it. So, some years ago, I did study electronics a little bit, but I have forgotten most of what I've studied, so this is kind of a refresher for me. But for people who have never studied electronics, this will definitely be beneficial. So, when we talk about electronics, we want to talk about the theory of it and some basics about terminology and how things are calculated. So first of all, what we need to understand is the relationship between voltage, current, and resistance. Current being the amount of charge carried by electrons passing a point in a wire per second. So that's a rate of passing electrons. That's the current. Voltage is the current will not flow without something influencing it, which is the purpose of voltage. And that voltage, to make any sense, it must refer to 2 points, which is the higher the voltage, the positive voltage is marked with a plus, and I don't know why I didn't have it there. It is a difference in voltage that makes a current flow in a wire. I'll put that bolded. It's a big point to understand. If there's no difference in voltage between one end of the wire to the other and another, then no current will flow. Okay, so that's an important point. Now, let's talk about how voltage, current, and resistance is calculated. When we talk about resistance, we talk about something called Ohm's law. It's named after a man by the last name of Ohm. Now, Ohm's law states that the current flowing through a wire or electronic component I will be the voltage across the wire or component of V divided by the resistance of the component. So therefore, I equals V divided by R. If it is the voltage you want to calculate, then this formula can be arranged, and you can arrange it 3 different ways. And if you know the current, sorry, I don't know why I put and. It's okay. If you know the current flowing through a resistor and the voltage across the resistor, you can calculate the resistance using, well, I would put therefore, but I just put using. Let's move this back up. So we have I, which is the current, equals voltage divided by resistance, or voltage equals current times resistance, or resistance equals voltage divided by current. Okay. Now let's talk about what these are. So resistance is the ability for a substance to resist the flow of current. Okay. So this is stopping the current. It's kind of like slowing. It's kind of like the analogy I like to use is like a pipe. So you have the water, that's the current, right? Then you have, you have the power, you have the push of the water, what they call, that's the current. The water itself is the voltage. The resistance is the force, such as maybe a force that's stopping the current from moving. Okay, so that's basically what it is. Now, let's talk about something important called Kirchhoff's current law. Now, Kirchhoff's current law says that at any point in the circuit, the current flow into that point must equal the current flowing out. So current flowing in must equal current flowing out. Okay, so that's as simple as that. Now, Kirchhoff's voltage law applies until you look at the polarity of the voltage. So let's talk about power now. Okay. A polarity is the plus and the minus. Those are two opposites, okay? You need the plus and the minus for there to be electricity. Okay, now let's talk about power. So power, I'm gonna just move this over to the next page. Power in electronics, power is the rate of conversion of electrical energy to some other form of energy, usually heat. So what happens is the byproduct is heat. It is measured in joules of energy per second. So joules per second, which is also known as a watt. Okay, so joule is the unit of energy, rate is the second, and the watt is the and then the watt is the measurement of the power, which power equals joules divided by the meaning energy, joules of energy, or energy divided by rate, technically, equals watts. That will give you your power. Now you can calculate the amount of power converted to heat using the formula. If you know the voltage across the resistor and the resistance of the resistor, then you can do power equals voltage squared. That's voltage times voltage. So power equals voltage squared times resistance. Okay, that's the formula. Now let's talk more specifically about practical things. Now, you may have heard of AC or alternating current. Now, AC, we're not talking about air conditioning, but we're talking about alternating current. In AC circuits, electrons periodically change direction. One way to think of it is imagine a river constantly reversing its flow. The voltage and current also reverse direction along the electrons, typically at a frequency of 50 hertz, which is the frequency, or 60 hertz depending on your location. This is the type of electricity delivered to your home through outlets. So when you plug something in, it comes in through AC. Okay, and then what happens is, in a power, well, I'll talk more about that in next lessons. There is a conversion from AC to DC for electronic circuits, okay? Because you cannot have 110 volt AC going through a circuit because it would fry it. It would be too much, more than it can handle. It's kind of like overflowing a cup. Yeah, sort of like that. So there is a conversion. I don't recall what it's called. There is a conversion between AC to DC. So in a power supply, what happens is it regulates the voltage by converting AC to DC. Okay, so what it does, first thing it does is steps down the voltage coming in through AC, and it converts that source to a direct current, from alternating current to direct current. Now let's talk about what direct current is. Now direct current in DC circuits, that is like in electronics, so you think like in computers, etc. The electrons flow in one constant direction. Okay, it doesn't go back and forth, it goes in only one direction. Think of a steady stream of water flowing into a pipe. The voltage and current also remains constant, will also remain constant on a DC circuit. Example of DC sources include batteries and solar cells. You could probably think of other examples too. Now the first thing to notice is that voltage flows in the shape of a sine wave. So if you want to look at it mathematically on a graph, you'd see a sine. Okay. Right now, I could talk more about the graphing, the geometrical patterns, but it's called a sine wave. Now, so gently increasing until it exceeds 150 volts, then heading down past 0 volts, around to minus 150 volts, and then back up again, taking about 16.6 thousandths of a second. So that's 16 over 1,000. Otherwise known as milliseconds, or ms, to complete one full. So it's 16 milliseconds, or ms, to complete one full cycle. The relationship between the period of AC, which we talked about AC before, time taken before one complete cycle, and the frequency of, let me move this over because this didn't come out right when I typed it. The AC number of cycles per second. Now frequency, that's lowercase f, not capital F. Lowercase f equals 1 divided by the period in terms of time. Now period is a classification. It's another word for saying time, okay? So we need to know over what period of time is a fundamental relationship in many areas of science and engineering that you could also use. So whether it's computers, whether it's this or whether it's that, this is what they use universally. It describes the connection between how often something repeats in terms of a frequency. That means how many times come over time, and the time it takes for one complete cycle for that repetition for the period. Okay, period is the amount of time, and frequency is how much over time. Now, like as I said, frequency, that's lowercase f measured in hertz. This is the name for the frequency, otherwise known as capital H lowercase z. It represents the number of cycles that occur in 1 second. It tells you how often a repeating event happens. Now, period capital T is measured in seconds. Okay, that is lowercase s, not capital S, but lowercase s, and represents the time it takes for one complete cycle of the repeating event. I'd like to conclude for this one lesson that I studied that you may be wondering why AC from an outlet is described as 110 volts when it actually manages to swing in a range of over 300 volts from peak to peak. The answer is that the 110 volt figure is equivalent to DC voltage that is capable of providing the same amount of power. This is called the root mean square. In voltage, it is the peak voltage, means the most voltage you can will use or whatever contain. So the peak voltage divided by the square root of 2. So square root of 2 is like 1.4 whatever, 1.41, 1.4 whatever. So you take the peak voltage, you divide it by 1.41 or 1.4. So in the preceding example, the peak voltage is 155 volts. When divided by 1.41, results of roughly 110 volts RMS. Remember, RMS is root mean square. This is kind of an interesting, lesser known concept, but this is how they calculate it, so it's kind of interesting to know. All right, now, I'd like to thank you for taking the time for watching this video, as you could be watching any other educational videos or anything else. So I'd like to thank you for that, as I do appreciate it. What I'd like you to do, as I know this did provide value for you, especially if you're interested in electronics, is I'd like you to please click like on the video. That way I'll be pushing the algorithm and more people will be able to view it, and enjoy and benefit from the knowledge that I have here. And this is what is an ongoing series, so stay tuned for that. Now, as I said, every day or every other day, Monday, at least Monday through Friday, sometimes Saturday. Saturdays I'll have other things I upload, such as gaming and other things like that. So if you haven't already, please click the subscribe button. That way I'll have access to all of my content on my channel, as I do have a variety of content on this channel, not just, technology. I have all types of things, okay? And that's what I'm uploading, as I was mentioning. Also, if you haven't already, please click the bell button. That way you'll be notified of all my future videos. That when it comes out, all my new videos, that way you won't miss any of them. And you'll be able to see this in the order that they came out. So I'd like to wish you a great day wherever you are in the world. Take care.